Hello, welcome once again to my channel. In this video, we are going to continue with probability distribution, and our mind will be centered on the Poisson distribution. If this is your first time or viewing, kindly consider subscribing to my channel. It gives you notification whenever a new video is uploaded. Now, the Poisson distribution is one of the discrete probability distributions that is utilized when the population size is so large and the probability of making a success is too slim. Just like you can see here, the population is up to 1,000 in this problem here. So it's a large population and you have to consider using the Poisson probability distribution. Okay, now the Poisson distribution is given by probability of getting a particular sample equals lambda x multiplying exponent negative lambda all over x factorial, where this lambda is just the mean, x is the sample size you want to test, exponent is 2.718 over x factorial. Now, properties of the Poisson distribution. One property of the Poisson distribution is that the mean is lambda. Another one is that the standard deviation is square root of lambda, and the variance is lambda as well. So from these things we've learned, let us utilize it in solving this problem at hand. So we are told here that 0.2% of the clocks produced by a machine were found to be defective. Find the probability that 5 out of every 100 clocks would be defective. 5 out of every 100 clocks. Now, 0.2% of the clocks. 0.2%, remember that the mean, which is lambda, is equal to NP, and our N is just 1,000 to 2 population, and our P is 0.2%. 0.2% means 0.2 over 100, and 0.2 divided by 100 will give us 0.02. 0.002. Okay, so our lambda will now be NP, which is 1,000 multiplying 0.002. So lambda will give us just 2. Now we've got the lambda. Remember that our x is just 5. The sample we are testing, our x is 5. So this is what we are going to plug in this function here to get the required probability. Now, the required probability will give us probability of 5. Will give us lambda. Lambda is now 2 power of 5 times exponent, which is now 2, or rather let me call it exponent negative lambda again. I'll have it as 2 because my lambda is 2 all over 5 factorial. Now, to apply the knowledge of indices to make this simpler, 2 power of 5 is 32 over 5 factorial times e squared, because from indices, when this negative power comes down again, it becomes positive. So I have it as 32 over 5 factorial is 5 times 4 times 3 times 2 times 1. Then times e is 2.718, then power of 2. This will now give us 32 over, so let us get 5 times 4 is 20, 20 times 3 is 60, 60 by 2 is 120. So have it as 120 multiplied by 2.718 all squared. 2.718 all squared will give us 7.387524. Now we have it as 32 over, so you multiply by 120, we shall get 886.5. Then we now say 32 divided by 886.5. 32 divided by 886.5. It will give us 0.036 approximately. This is the required probability. So the probability that 5 out of every 1000 cogs will be defective is just 0.036. So if you've enjoyed what you've watched, kindly consider subscribing to my channel so that you don't miss any content whenever a new episode of this topic comes out. Thank you.